Floods are a serious natural disaster. They cause damage and displace people. Predicting floods is important for saving lives and property. In the past, we used historical data to predict floods. Now we have new technologies like GPS, sonar, and soil sensors. These technologies help us predict floods more accurately. Early warning systems use this data. They alert people about potential floods. This gives people time to evacuate and protect their belongings. This essay will explore how these technologies work together. We will see how they are revolutionizing flood prediction. GPS stands for Global Positioning System. It uses satellites to pinpoint locations on Earth. In flood prediction, GPS helps monitor changes in water levels. It does this by tracking the movement of buoys placed in rivers and streams. As water levels rise, the buoys also rise. This data is transmitted to ground stations via GPS satellites. Scientists then analyze this data to understand water flow patterns. This helps predict potential flood zones. Sonar stands for Sound Navigation and Ranging. It uses sound waves to map the underwater environment. In flood prediction, sonar helps determine the depth and volume of water bodies. Sonar devices emit sound waves that bounce back from the riverbed or lakebed. By measuring the time taken for the sound waves to return, we can calculate the depth. This information is crucial for understanding the water storage capacity. It helps predict when a water body might overflow. Soil sensors are placed underground to monitor moisture levels. They provide crucial data on how saturated the ground is with water. When soil is saturated, it cannot absorb more water. This leads to surface runoff and increases the risk of flooding. Soil sensors measure the electrical conductivity of the soil. Water conducts electricity better than dry soil, so higher conductivity indicates higher moisture levels. This real-time data helps predict how much rainfall will infiltrate the ground versus becoming runoff. Section 5: Algorithms at work processing the data deluge. Data from GPS, sonar, and soil sensors is vast and complex. Algorithms help make sense of this data. Algorithms are like recipes. They provide step-by-step instructions to process information and produce meaningful results. In flood prediction, algorithms analyze the collected data to identify patterns and trends. For example, an algorithm might correlate rainfall data with changes in river water levels. This helps establish a relationship between rainfall and flood risk. Section 6: Predicting the deluge equations for early warning. Mathematical equations form the backbone of flood prediction models. These equations use data collected from various sources to estimate flood risk. One commonly used equation is the runoff coefficient. Runoff coefficient, or C, equals runoff volume, R divided by rainfall depth, P. This equation calculates the proportion of rainfall that becomes runoff. A higher runoff coefficient indicates a greater flood risk. Other equations consider factors like soil infiltration rate, topography, and river flow velocity. Section 7: Case studies, success stories in flood forecasting. Several countries have successfully implemented advanced flood prediction systems. For example, the Netherlands, known for its low-lying terrain, uses a sophisticated system that integrates real-time data from various sources. This system provides accurate flood warnings, allowing for timely evacuations and minimizing damage. Similarly, the United States has implemented the Advanced Hydrologic Prediction Service, which uses similar technologies to predict floods across the country. Section 8: The future of flood prediction, a wave of innovation. The future of flood prediction is bright with technological advancements. Artificial intelligence, or AI, and machine learning, ML, are being integrated into prediction models. These technologies can analyze vast datasets and identify complex patterns that humans might miss. Furthermore, advancements in sensor technology will provide even more accurate and real-time data. Imagine drones equipped with sensors that can monitor vast areas quickly and efficiently. This data, combined with AI and ML, will revolutionize flood prediction. Section 9: Conclusion: Riding the crest of algorithmic flood prediction. Flood prediction has come a long way from relying solely on historical data. Today, technologies like GPS, sonar, and soil sensors provide a wealth of real-time information. This data, processed by sophisticated algorithms and mathematical models, empowers us to predict floods with greater accuracy. As technology continues to evolve, we can expect even more precise and timely flood warnings. This will save lives, protect property, and create a more resilient future for communities vulnerable to the devastating impacts of floods.